Writing equations for word problems. So this particular problem says an airplane 30,000 feet above the ground begins descending at the rate of 2,000 feet every minute. Assume the plane continues at the same rate of descent. The plane's height and minutes above the ground are related to each other. So the very first one says, if f of x represents the feet above ground the plane is after x minutes, write a function to model the situation. Okay, so let's kind of break this problem apart. So this is saying that an airplane is 30,000 feet above the ground when it begins. That tells you right here that this is your starting number, our initial number. This is our y-intercept when we write our function. As we read through here, I call words like every magic words, like every, per, each, any, a. So every is close to the number 2,000. So that means that 2,000 is my slope. So then the word that comes after my, what I call my magic word, minutes, that represents my x. Okay. So one thing that, as a reminder, f of x is the same thing as y. And also another thing to think about is descending means decreasing, which represents a negative integer. So we've already talked about what slope-intercept looks like. That you have your y, it is equal to your slope times x plus your y-intercept. So if 30,000 is my y-intercept, and I am dropping or decreasing 2,000 feet every minute, the 2,000 would need to be a negative integer being multiplied to my x, which was minutes, added to my starting number, which was my 30,000. On the second one right here, they're saying, suppose the airplane was descending at 3,000 feet every minute. So using the same information from above, the only thing that you're changing in this is the slope. So the slope is the only thing that changed. So it still started at 30,000, but instead of dropping at 2,000, it's dropping at negative 3,000 feet per minute.